Hey, eighth graders, this is Mrs. Johnson. I'm filming this from my house, which is why the background looks different. All right, we are on page 94 in your math binder, and we are doing a page of good notes called Dilations. We're going to talk about dilations. They're kind of like the next step after translations, rotations, and reflections. And they're like that dragon task that we saw where the dragon got stretched or shrunk. So here's the definition of dilation. It is going to be, I'll get my face out of the way, a transformation that keeps the shape but changes the side of a figure or the size of a figure by a scale factor of K or R. You'll see both of those letters. I think on a lot of these I use K, but sometimes you'll see the scale factor R, so just know it can be either way on your end of year tests. So it's a translation. By the way, you're writing this down. This is in your notes. It's just on the screen this time. A translation or transformation that keeps the shape but changes the size of a figure. Oh, I kept saying that wrong. Okay, in the following problems, one figure has been dilated to obtain a new figure. Determine the scale factor and coordinate rule for each dilation. So we are going to start with number 1. On number 1, you can see that ABC has been dilated to form A prime, B prime, C prime. So we need to decide what is the scale factor and what would be the coordinate rule here. Well, if I look at some of these coordinates, you can see that A and A prime are in the exact same place. They're both at the origin. But some of these other ones, if you look at B, for example, B is the coordinate to the right 3, up 0. So what does it take to get to B prime over here? Well, B prime is to the right 1, 2, 3, 4, 5, 6, right, B prime, to the right 6, up 0. Okay, so we can see a little clue here. How do I go from B to B prime? Let's look at C to C prime. C is at, right here, to the right 3, up 4, so 3, 4. And C prime is to the right 1, 2, 3, 4, 5, 6, up 8. Are you seeing that pattern? How did we get from B to B prime? And that same pattern, how did we get from C to C prime? Well, notice my X value, 3, became 6 by multiplying by 2. And then 3 became 6 by multiplying by 2. 4 became 8 by multiplying by 2. Now, if we look at A, which was at 0, 0, going to A prime, which is also at 0, 0, technically that can multiply by 2 as well, because again, when we're multiplying 0 by a scale factor, it doesn't change it. So our scale factor here, we can say K, the thing we're multiplying by, is equal to 2. Our scale factor is 2. So what is the coordinate rule? Here's how we would write our coordinate rule as an ordered pair. We would say that you start with the original X, Y coordinate. And then we're going to draw an arrow to show that each of the X coordinates gets multiplied by our scale factor. So we'd say 2 times X, and each of our Y coordinates gets multiplied by the scale factor, 2 times Y. The reason we can't just multiply either X or Y is because then it shows up like that dragon task where it just stretched or stretched in the other direction. We wanted to stretch in both directions, which is why we multiply both the X value and the Y value by the scale factor. Here's another cool thing you could have done to find the scale factor. Do you see how AB is 3 spaces long? Well, A prime, B prime is another horizontal stretch where I can see that that is 6 spaces long. So we also could have just said, okay, well, this side length that I know is 3. The side length on the similar image is 6. So from 3 to 6, we multiplied by 2. Now, that's not going to work on problem number 2 because as you can notice on problem number 2, none of these are simple ones where I can just count how long AB is or BC or CA because they're slanted. So we are going to look at some ordered pairs. Now, I don't care which ordered pair we pick, it will always follow the same one because we know it's been dilated. So it'll always follow the same rule, whatever that rule is going to be. So let's check out, let's go with A. I know that A is up here, and that is to the right 0, up 9. So 0, 9. Now, I know that that one came first because it doesn't have a prime on it. This one right here, A prime, has the prime on it. So I have to put that as second. So A prime is to the right 0, up 3. Now, how do I go from 9 to 3? Well, it's dividing by 3. But when we're looking at this mathematically, we can't say that the scale factor divided by 3. We have to say something that it multiplied by. So when we're dividing, it's really multiplying by the reciprocal. So we could say that the thing we multiplied by here is actually 1/3. Multiply by 1, divide by 3. And that's how multiplying by fractions works. We divide that denominator. Okay, so our coordinate rule, we still start off with our x comma y, but now the x values are thirded and the y values are multiplied by 1/3 as well. Saying the word thirded sounded weird. Okay, so we see how it affects something like this. I'm going to clear this off. If you haven't already finished off this page, make sure you do so. And let's go to the next page, the next part of the notes. Okay, so on this one, it says, fill in the blanks. And I'm going to move my face out of this screen again. So it says, when two figures have the same size and shape, do you remember what we call that when they have the same size and shape? They are called congruent. That's totally spelled wrong. It should say congruent, not congruent. But when two figures have the same size or shape, but not necessarily the same size, they're what we call similar. It's pretty obvious. Yeah, two things are similar, but in mathematics, it means that the shape is the same, but the size of the shape is not the same. So we are going to use that idea on these next few pieces of information. So let's start by looking at problem number 3. Write the coordinate rule for a dilation with the center at the origin and the given scale factor. Then draw the image of each figure after the dilation. Then write a similarity statement from each picture. So let's start by writing the ordered pair. If we know, again, here I'm going to use R instead of K, totally fine. If we know that R or K is multiplying by 3, we need to change our rule to say 3 times the X values, comma, 3 times the Y values. So when I take my original 3 ordered pairs, I would have A, which is at 0, comma 3. I have B, which is at 2, comma 3. And C, which is at 0, comma 0. All right, so I have those pre-image points. Those are the ones that came first. Now I'm going to dilate them to get my image points. So I know I'm going to get A prime, B prime, and C prime. Now my rule tells me that all my x's multiply by 3 and all of my y's multiply by 3. So 0 times 3 is 0. 3 times 3 is 9. 2 times 3 is 6. 3 times 3 is 9. 0 times 3 is 0, and 0 times 3 is 0. All right, so that kind of creepily looks like a face, but here's a similarity statement here. We are going to say that triangle ABC is similar to triangle A prime, B prime, C prime. So why is that? Well, let's look at this. When I graph it, A prime is right here. B prime is to the right 6 up to 9. And C prime is at 0, 0. And when I connect these, oh boy, they are the same exact shape, but the primes were just enlarged. So I'm going to use this symbol. It's not the congruent symbol, which has an equal sign underneath it. Congruent means same size and shape. This one is similar, which is just going to be that single squiggle. ABC is similar to A prime, B prime, C prime. Let's try another one. Let's try problem number 4. So if you look at problem number 4, you are told that it is multiplying by 1/2. So my coordinate rule is going to be 1/2 times x, 1/2 times y. And when I have my original coordinates, I don't know why I said A. Oh, there is an A. Let's go with A, D, Q, U. Well, A is at 8, comma 4. D is to the right 2, up 2. Q is to the right 2, up 4. And U is to the right 6, up 6. So now when I transform those, I'm going to take them to A prime, D prime, Q prime, U prime. And typically there's like a little arrow here. Okay, so I'm having each of the X values and each of the Y values. So half of 8 is 4. Half of 4 for my Y value is 2. Half of 2 is 1. Half of 2 is 1. Half of 2 is 1. Half of 4 is 2. Half of 6 is 3. Half of 6 is 3. So let's graph the image. So I'm going to go to the right 4 up 2, and I'm going to label that A prime. Don't forget to label as you go. You don't want to do it at the very end because you might mislabel something. D prime is at 1, 1. Q prime is at 1, 2. And U prime is at 3, 3. Now, you'll notice the last one we did, oh, that was a bad connect the dots. Problem number 3 was an enlargement because it got bigger. Problem number 4 was a reduction or a shrink. It got smaller. How can we tell that just by looking at it? Well, you'll notice, oh, that's a bad circle. On that one, we were multiplying by 3. And on this one, we were multiplying by 1/2. So you can see that one of them is multiplying by a number that's smaller than 1, or a fraction of 1, and the other is multiplying by a number bigger than 1. So 1 would kind of represent that in between, that stay exactly the same amount. Anything bigger than 1 is going to represent getting bigger, and smaller than 1 will be smaller. So your job right now is to finish numbers 13 and 14. I'm going to go over them quickly when you are done, but I suggest that you actually try your best on these because they're really great for showing whether or not you are ready to do the practice on these things. So move on to problems number 5 and yours labeled 13 and 14, mine are. Move on to the next 2 problems. Push pause. Many of you might have noticed that I forgot to do the similarity statement here. This should have been, before I cleared it off, quadrilateral, but we don't draw a quadrilateral. We would just say A, D, Q, U is similar to A prime, D prime, Q prime, U prime. Simple as that. Okay, now we're going to move on to the next page. Okay, many of you have already done this next page, so I'm just going to go over it. I'm going to start with problem number 13. On problem 13, you can see that it says you're multiplying by 1/3. So we had 1/3 x, 1/3 y. My original coordinates were r, 0, 3, s, -3, 6, t, -9, -3. And when I use my rule of 1/3 x's, 1/3 y's, I get r prime at 0, 1, s prime at -1, 2, and t prime at -3, -1. And I can see that this was a reduction or a shrink, and triangle RST ended up being similar to triangle R prime, S prime, T prime. Okay, let's look at the other side. On number 14, R equals 3. I already knew that was going to be an enlargement because that number is bigger than 1. So XY becomes 3x, 3y. And you can see I had R, S, T, U. And all of those numbers tripled to be R prime, S prime, T prime, U prime. And the picture, the image was way bigger than the pre-image. In fact, it was triple the size of the pre-image. And we just wrote it out as our similarity statement, R, S, T, U is similar to R prime, S prime, T prime, U prime. Notice you might have used these in a different order. Totally fine if you said like S, T, U, R. The only thing we typically do is we pick a letter to start at, and then we go in a circle from there because it tells you what order to draw them in. But other than that, that's all we got for today's notes. Hopefully you can do the practice. Let me know if you have any questions on this stuff. But yeah, otherwise good luck on your dilations.